Okay, now, hello. So this is the topic of last lecture, synthesis of pyrrole. Okay. So in that lecture, we are studied about the how to synthesize the pyrrole from various substrate. Okay. So there are three examples and three methods are given for the synthesis of pyrrole. So first is a preparation of pyrrole from succinamide in presence of zinc and heat. Okay, so there is succinamide reduce. It is a reducing agent, act as a reducing agent. Okay, and it reduce this C double bond O and convert into the CH2. So you can see here. You can see here this C double bond O and this C double bond O. This C double bond O. Okay, just a minute. Okay, so this C double bond O and this one, it is reduced and converted into the CH2 in presence of the zinc. Zinc is a metal which is gives electron to the this carbon and then it converts into the anion and after reduction it converts into be this group. Okay, so CH2 is there. So this succinamide is converted into the pyrrole ring. Okay, this is the one of the method for the preparation of pyrrole. Okay, the second one is here. You can see here, this is the furan. This is the furan. I'm audible for everyone? Hello.
Yes, sir.
Okay. So now we can see this is the second method is here. This is a furan. And when furan is react with NH3. Okay. NH3 is ammonia, is a base, and it take this oxygen with the help of this two hydrogen from this and loss of the H2 molecule and this NH bond, NH insert in between to this carbon here. Okay, so that furan is converted into the pyrrole. Okay, similarly, the one of the method to preparation of pyrrole by using the acetylene. Okay, so there are two acetylene molecules. So 2 raised to 1 reaction is there. So this 2 is react with the ammonia and then it pass through the red hot tube. So you can see this is the product as a pyrrole. So dear student, are you visible this slide? Hello. तुम्हाला स्क्रीन दिसत आहे का?
Yes,
हॅलो.
sir.
Sir. Yes, sir.
ओके, आवाज येतोय माझा क्लिअर?
Yes, sir.
Okay.
Yes, sir. Yes.
Next. So let's see here now. This is one of the method. It can be used for the preparation of the pyrrole, but it is not mentioned in your syllabus. But for your kind information, you have to know this, know about this reactions. This reaction is known as Knorr pyrrole synthesis method for the preparation of pyrrole. Okay, so this is very good method for the preparation of pyrrole. You can see here, this is the one of the molecule is here. This is containing the amine and one carbonyl group and another molecule is this type of beta diketone. Okay, so these two react with each other and form this type of molecule. This is called as to be pyrrole. But there is a substituent. Okay, there is substituent along with this ring. Okay, so substituted pyrrole, it can be synthesized very easily by using this method, but it is not purely utilized for the preparation of the pyrrole. Okay, okay, so that's why it is not mentioned in your syllabus because we are studying about the pyrrole. It is the basically syllabus we are going to be studied here. So this is not a part of your syllabus. Only three methods are given for the preparation of pyrrole. So this first from the succinamide, second from the furan, and third from the acetylene molecule. Okay. Then next topic is very much important and it is very much helpful to understand the structure of the pyrrole ring. Okay, so if you know the structure, then you can be understand their nature and their reactivity of the pyrrole. Okay, so that point of view, it receives so much important in the study of pyrrole uh, molecule or heterocyclic compound molecule, because from the structure you can understand their bonding nature, their orbital nature, and their electron, how to be delocalized, what is the hybridization, what is the bond angle, what is geometry, that and their nature, whether it is nucleophile or electrophile. So these all things are to be related with the structure. Okay. So molecular structure study of the molecule is much important. So initially, if you see this pyrrole molecule, so in pyrrole, you can see this type of structure, 5-member ring is there. One is nitrogen, is a heteroatom, and 4 are carbon along with the hydrogen. And here one double bond, and on this, in between to this carbon, there is also double bond, and lone pair of electron on the nitrogen bonding with the one hydrogen. Now you can see in this molecule, there is a, firstly, if you think about the molecular formula, so you can say about the molecular formula. So you can count the number of carbon. So there is number of carbon in this molecule is 4. Okay. The number of hydrogen you can count the one hydrogen from this, one from this, one from this, and from this. So there is a 4 hydrogen, and next one is here. So there is a total, how much hydrogen in this molecule? Hello, 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 hello.
Yes, sir.
अरे मी काय विचारले, याच्यामध्ये किती हायड्रोजन आहे, ऐकायला येत आहे का सगळ्यांना, की बंद करून बसले?
5 हायड्रोजन आहेत सर.
येस येस. अरे तुम्ही बोलत का नाही रे, सगळेजण एवढे गप्प बसून जाता? हा, बोललं पाहिजे ना, मला समजेल ना की आपण 2 वे डिस्कशन चालू आहे म्हणून इथे. ओके, लक्ष ठेवा. Okay, 5 hydrogen, and number of nitrogen is a 1. Okay, so this is simply the formula of pyrrole, C4H5 and N. Okay, the next thing is here. Now we talk about the hybridization. Okay, so if you see in this molecule, these carbons are present in sp2 hybridization. Okay, carbons are present in sp2 hybridization, and there is a nitrogen, which there is no double bond initially in around this nitrogen, so it is present in sp3 condition. Okay, but the one of the orbital of nitrogen, this contain the lone pair of electron, that is the 2pz. Okay, there is a lone pair of electron, and in the 2px, 2py, and 2p, 2s, 2p, and this mix and recast, and it forms the 3sp2 hybrid orbital, okay, which contains the single electron, and it forms the 3 sigma covalent bond with the 2 carbon atom and 1 hydrogen atom. Okay, but one of this orbital having the lone pair of electron on this nitrogen. That's why it contains the lone pair of electron. Okay, so uh, this is the structure of pyrrole ring. Okay, initially unhybridized atomic orbital. There are 2s. It is 2 electron, and there is a 1 1 1 that is unpaired electron. Okay, but 1 electron move from this to this, and it gives the 3 unpaired electron, that is the s and 2p atomic orbital mix and recast and form sp2 hybridized condition. Okay, and one this 2p is having the lone pair of electron. So this is the electronic distribution of nitrogen. Okay, in pyrrole ring. Then there are 2 type of structure in the pyrrole ring. One is the sigma structure and one is the pi structure. Okay, so these 2 types of structure means 2 type of bonding in the pyrrole. If you see this pyrrole, so this carbon, 4 carbon, then all this present in sp2 hybridized. Okay, sp2 hybridized means 3 sp2 hybrid orbital. Means it forms a 3 sigma covalent bond. Each carbon and hydrogen, they all are formed the 3 sigma covalent bond with nearer atoms. Okay. So in the pyral ring, you can see here, okay, this hydrogen, this carbon, it formed the one bond with this one s atomic orbital of the hydrogen, the second bond with this carbon, and third bond with this carbon. Okay, means it formed the 3 sigma bond, and this carbon having one unhybridized atomic orbital, p orbital. Okay, so each carbon in this, they having the one atomic orbital which is not participate in hybridization, and it is not involved in the sigma bond formation. Okay, so that means this unhybridized atomic orbital from each carbon. Now you can see here, this is the orbital which is not involved in the bond formation, sigma bond formation. Okay, so this carbon having this p atomic orbital, it is coaxial with the nearer or adjacent carbon. Okay, you can see here, ही ऑर्बिटल आणि ही ऑर्बिटल हे कसं आहे, एका ऍक्सिस मध्ये आहेत. ही ऑर्बिटल आणि ही सगळे कसे आहे, एका ऍक्सिस मध्ये आहेत. ओके, so because of that they can be overlap to each other by laterally. The sideways overlapping is there, and due to the sideways overlapping, it form pi bond. It form the pi bond. Okay, so here you can see there is a one carbon carbon bond. Means here one carbon carbon bond is formed by the pz atomic orbital overlapping with the adjacent carbon, and similarly this carbon pz atomic orbital, and from this carbon they laterally overlap and form another pi bond. Okay, so in this way, in pyrrole you can see there are two pi bond is forming between two carbon and carbon through the sp2 pz overlapping. Okay, and now here nitrogen, which having the lone pair of electron in a pz atomic orbital, this pz atomic orbital with lone pair of electron present in a same axis, it is present in coaxial condition with the pi bonding orbital. Okay, and due to that coaxial nature, this pi bonded electron from the nitrogen, this pi bonded electron from nitrogen, it is delocalized. It is delocalized with the another pi bonding orbital. Okay, so now you can see here this nitrogen gives electron to this carbon double bond, and then the double bond is open upon this carbon. Again, this negative charge delocalized with this carbon, and this double bond open upon this carbon. So in this way, in the pyrrole ring, there is a sigma structure you already seen here in between two the carbon and hydrogen bond, in between two carbon and this nitrogen bond, and one sigma bond in between to the carbon and this carbon. Okay, so in this way, 3 sigma bond is there. So you can simply see the sigma structure for the pyrrole ring. It's very simple. You can see here. There is a carbon, this nitrogen, and this nitrogen, and again this one. Okay, so like this. So this is to be the first sigma structure you can be say. ओके, याच्यामध्ये आपण सिग्मा बॉन्ड पाहतोय सगळे, म्हणून याला आपण सिग्मा स्ट्रक्चर म्हणतो आहे ना. आणि परत त्यामध्ये पाय बॉन्ड फॉर्म झाला की तो पाय स्ट्रक्चर होईल. बट हा जर बघितला आपण तर हा झाला त्याचा सिग्मा स्ट्रक्चर. ओके, सिग्मा स्ट्रक्चर, याच्यामध्ये पाय बॉन्ड राहणार नाही, हे पाय बॉन्ड इथनं आपण काढून टाकू, हे पाय बॉन्ड नसणार. So this is all are the sigma structure. But when there is the overlapping of this p orbital and form the pi bond, so you can see here there is a pi structure is also formed. So you will get this type of overlapping. So this structure is a pi structure. Okay, so two type of structure, two type of bonding in the pyrrole ring: sigma bonding, covalent bond, and pi bonding is also there. Okay, and in this pyrrole, this lone pair of electron from nitrogen, it is not easily available for donation to the another electrophilic species. Okay, so that's why this lone pair of electron engage with the delocalization of the another 2 pi bond. So that's why total 6 pi electron delocalize in the ring. Okay, so it shows their aromatic nature. The spiral ring aromatic in nature because of 6 pi electron in delocalization, and it follow the Huckel's rule. Okay, so this is all about the molecular structure of pyrrole. Then you can be see here the distribution of electron in bonding and anti-bonding orbital in case of the pyrrole. Okay, there are 4 different examples are given. This is the question, it was asked in any example, but I collect this question to understand how the electronic distribution can be understood from this question. So now you see here, this is the pyrrole, and you can see there are 2 pi bond and 2 electron from nitrogen. So total 6 pi electron involved in delocalization, and that's why it follow the Huckel's rule. So you can see this structure, B type of structure is here. And in this structure, you can see there are 6 pi electron in the delocalization in a pyrrole, and that can be distributed in this way. So first 2 electron in lower energy orbital, that is to be the bonding orbital. These 2 are the and non-bonding orbitals is there. So the total 6 pi electron and no any electron in antibonding orbital. Okay, so this is the for your kind information. You have to know how this electron is distributed. So yeah, you can understand their bonding and antibonding orbital nature, orbital and electronic distribution. So for just kind of information, I put this question in our lecture. So you can just keep in your mind. In this way, you can be distribute the electron in bonding and antibonding molecular orbital. But basically, here you have to be understand the pyrrole follow the Huckel's rule. That means the 4n plus 2 pi electron. Okay, so there is one ring is there. So one that n is equal to 1. So generally we are consider the number of ring is considered as n, but not exactly, because n is the number of non-bonding degenerated orbitals. Okay, degenerated orbital level. So in this electronic distribution, you can see there are 2 non-bonding uh, pairing is there, but these are present in a same energy level. So that's why it is called as the degenerated. Degenerated means अशी energy level की ज्या energy level ची energy ही सारखी असते, and जेवढ्या number of energy level असलेल्या सारख्या असलेल्या, that is equal to be the n value. Okay, this is the exactly about the pyrrole or aromatic in nature or Huckel's rule. So in this electronic distribution, you can see the distribution of electron here. This is the n value is equal to 1 because there is degenerated orbital for the distribution of electron is 1. है ना, हे जे दिसतात आपल्याला इथे ही एक आणि ही एक, त्या दोघांची एनर्जी लेवल सारखी आहे. मग अशा सारखे असलेली लेवल जी आहे ती एकच आहे है ना. म्हणजे इथे जर इलेक्ट्रॉन असतं, इथे इलेक्ट्रॉन असतं, या दोघांची पण एनर्जी सारखी आहे. ही एक डिजनरेटेड एनर्जी लेवल होऊ शकते है ना. मग ही एक पहिली डिजनरेटेड आणि ही दुसरी डिजनरेटेड. पण पायरॉल मध्ये काय होते, फक्त एकच डिजनरेटेड मध्ये इलेक्ट्रॉन आपल्याला फाउंड होतात आणि इकडे ते इलेक्ट्रॉन नसतात. म्हणून आपण n is equal to 1 consider करतो. And that's why if you put the value of n in Huckel's rule, you will get that 4n plus 2 pi electron is equal to be 6 pi electron in delocalization. Okay, and from that we can say this pyrrole is aromatic in nature because it follows the Huckel's rule. Okay, next. This is another representation. Okay, so now you can see here resonance structure of pyrrole. Okay, resonance structure of pyrrole means you know that nitrogen having lone pair of electron, but this electron does not available easily for donation to the another electrophilic species. Okay, so what happened here? Here, this lone pair of electron from pz atomic orbital of nitrogen, it is coaxial with the pz atomic orbital of another carbon, adjacent carbon. Okay, so due to this coaxial nature, This lone pair of electron, it delocalized with anti-pi bonding orbital of this pi, okay, pi anti-bonding orbital, and then due to this delocalization, completely this lone pair of electron from the nitrogen is delocalized over this all carbon nitrogen system, and due to that the two electron from nitrogen continuously delocalize and continuously engage in the delocalization in the ring. So that's why it follow the Huckel's rule. Okay, but due to the delocalization of lone pair of electron with the pi bonded system, we get the different resonating structure. Okay, and from that we can understand the resonance structure of the pyron. So here, due to the giving the electron from the nitrogen to this carbon, develop the double bond in between to carbon and nitrogen, and that's why you can see here the positive charge appear on the nitrogen. Okay, but this double bond is breakdown and negative charge appear on next carbon. Okay, now here this negative charge in the conjugation with this pi bond, and that's why this pi bond is again open upon this carbon. Okay, now you can see here. Okay, again there is a pi bond in the conjugation, so this negative charge delocalize and again this negative charge come on this carbon. So in this way you can see different resonating structure is obtained due to the delocalization of lone pair of electron of the nitrogen with the pi bonded um, conjugated system. Okay, so due to this overall delocalization, you can see here there are 6 pi electrons delocalized, and due to that delocalization, we are getting the different resonating structure. Okay, so now these three are the resonance contributors of the pyron. Okay, so their hybrid structure you can see here this way. Okay, so this is the resonating structure. Is very easy for our understanding, because we know that how the electron delocalize in the aromatic ring in a conjugated system. Okay, next evidence of aromatic character in pyrrole. Okay, the evidence क्या है aromatic साठी पहा. All ring bonds are intermediate between single and double bond. If there is a conjugation is there, okay, it tend to react by electrophilic substitution. Okay, means it's able to react with the electrophilic substitution. First one is the cyclic planar, then there is the alternate single and double bond, means there is the conjugation is there, and due to this nature it is able to react with the electrophilic species and give the substitution. That's why it gives electrophilic substitution reaction. So these are the properties of aromatic compound, characteristic of the aromatic compound. Then another is here, its exceptional lack of basicity and strong acidity as a second amine compare. Okay, means if you compare the basicity and acidity of the pyrrole with the another amine, so you can see simply basic nature is depend upon the lone pair electron donating capacity ability of the nitrogen. Okay, so in generally in aliphatic amine there are lone pair of electron on the nitrogen that are easily available for donation to the another species. But in case of pyrrole and in case of aromatic compound which having the nitrogen or heteroatom which possessing the lone pair of electron, so that lone pair of electron not easily available in case of pyrrole, because this lone pair of electron delocalize with the conjugated system. Okay, means this lone pair of electron engage with the delocalization. Okay, हा जर इथे डिलोकलाइज मध्ये जर एंगेज झाली असेल लोन पेअर ऑफ इलेक्ट्रॉन, तर दुसऱ्याला द्यायला लोन पेअर ऑफ इलेक्ट्रॉन इथे अवेलेबल नसणार. आणि अशा कंडिशन मुळे म्हणजे अकॉर्डिंग टू द लेविस कन्सेप्ट यू कॅन से देयर इज अ low ability of this nitrogen to giving electron to the electrophilic species. That's why it is acted to be very weak base. Okay, you know, and but there is a NH bond. Okay, NH bond, and in the resonance structure we already see, we can see here there is a positive charge develop on the nitrogen. Okay, and we know that due to the positive charge, the electronegativity of the nitrogen is increases. Okay, असं जर नायट्रोजन आहे आणि नायट्रोजन वरती काय आहे, पॉझिटिव्ह चार्ज आहे. ओके, मग आपण इथे काय म्हणू शकतो की हा जो काही NH बॉन्ड आहे, त्या NH बॉन्ड मधले नायट्रोजन ऑलरेडी मोर इलेक्ट्रोनिगेटिव्ह आहे आणि म्हणून हा जो बॉन्डिंग इलेक्ट्रॉन जे आहे इट इज शिफ्टेड टुवर्ड द नायट्रोजन सेंटर. Okay, but due to the positive charge, their electronegativity again increase. Okay, it is more than the neutral nitrogen atom. Okay, so that's why their drifting electron from the sigma bond, NH bond towards this nitrogen is become to be increases, and that's why this hydrogen become ready to depart as a H positive. Means this pyrrole molecule it can give easily H positive. Okay, so that nature is related to the acidity or acidic nature of the pyrrole. Because if it gives the H positive very easily, so it acts as to be acid. Okay, and it is very weakly give electron to the another species. That's why it is to be the very less basic in nature. Okay, in this way. So if you consider these two molecules here, one is pyrrole and second one is the pyrrolidine. Okay, means there is one aromatic compound and second one is a aliphatic compound is there. Both are the cyclic, no matter. Both are the cyclic, but this is the aromatic molecule and this is not an aromatic molecule. And the lone pair of electron from this nitrogen in a pyrrole, it is engaged in the delocalization. But in pyrrolidine, you can see here, this nitrogen is sp3 hybridized. sp3 hybridized means there is no pi bond. Okay, only sigma bond is there. And this lone pair of electron is not engaged with the delocalization. In the delocalization, that means this lone pair of electron easily available for the donation to the another electrophilic species. Okay, so you can say this electron is easily available for donation, so that's why it is basic in nature. And here lone pair of electron engage in delocalization, that's why it is acidic in nature and very weak basic in nature. Okay, so in this way we can understand the aromatic nature, aromatic characters in pyrrole, and also the basic nature and acidic nature comparatively. So in this slide we are going to be understand about the basicity of the pyrrole. It's very simple concept we already discussed here. So lone pair of electron, availability of lone pair of electron decide the basicity. If there is a availability is very strongly for the donation to the another electrophilic species, then this species become to be more basic. And if this lone pair electron does not available for the donation to the another electrophilic species, then this species become to be very weak basic in nature. Okay, so very simply, so now when this aromatic compound pyrrole is react with the acid, okay, acid. So what happened if this electron from the nitrogen gives to this proton and then this proton bond with this nitrogen, and you can see here, okay, here positive charge on the nitrogen and two hydrogen bond with this nitrogen. Okay, so here there is no lone pair of electron on nitrogen is available for the delocalization with this conjugated system. That means we can say here pyrrole in neutral condition it is aromatic in nature because 6 pi electron in the delocalization, but here only 4 pi electron in delocalization. Okay, that's why it is not aromatic in nature, non-aromatic in nature, and it is somewhat unstable as compared to this species. Okay, from that we can say it does not abstract the proton, does not abstract the proton by the nitrogen. Nitrogen वर हा proton abstract करत नाही, म्हणजे हे लोन पेअर ऑफ इलेक्ट्रॉन जे नायट्रोजन वरती आपल्याला दिसतात ते इलेक्ट्रॉन दुसऱ्या कुठल्याही इलेक्ट्रोफिलिक स्पेसिसला दिल्या जाणार नाही, ते या डिलोकलायझेशन मध्ये एंगेज राहणार. आणि अशा केस मध्ये मग आपण याला काय म्हणू शकतो की याचे बेसिक नेचर जे आहे म्हणजे इलेक्ट्रॉन देण्याची जी त्याची अबिलिटी आहे ती कशी आहे, वीक आहे म्हणून त्याला आपण वीक बेसिक असं म्हणतो. ओके. And for your kind information, keep in your mind, all the aromatic amines are the weak basic in nature. है ना? aromatic अमाइन जे असतात ते सगळे कसे असतात, वीक बेसिक असतात, कारण त्याच्या लोन पेअर aromatic नेचर म्हणजे aromatic रिंग सोबत काय असतात एंगेज असतात. ओके. नेक्स्ट basicity measured of how radially on carbon donate its electron pair to the proton. Nitrogen containing heterocycles are basic unless unshared electron pair of nitrogen is conjugated with pi. Means आपण इथे काही नायट्रोजन हेटेरो ॲटम असलेले अरोमॅटिक कंपाऊंड इथे पाहतो आहे आणि या कंपाऊंड मध्ये जसा हा पिरिडीन आहे, हा पायरॉल आहे आणि हा इमिडियाझोल आहे, असे वेगवेगळे नायट्रोजन कंटेनिंग हेटेरोसायक्लिक कंपाऊंड आहे. आणि या पायरॉल मध्ये जर आपण इथे पायरॉलचा स्टडी करतो आहे, जर हे इलेक्ट्रॉन नायट्रोजन वरचे जर अरोमॅटिक रिंग मध्ये एंगेज होत असेल तर ते दुसऱ्याला द्यायसाठी अवेलेबल राहणार नाही. सिंपल आपण इथे याला कम्पेअर करू शकतो. म्हणजे इथे जर पिरिडिन मध्ये बघितलं, ठीक आहे, आपण हा कन्सेप्ट नंतर स्टडी करू. Acidic character can be explained by two factors. Due to greater S character in the NH bond in pyrrole, the bonding electrons are held more strongly, okay, to the pyrrole nitrogen, so hydrogen is eliminated as a proton. ओके. ऍसिडिक कॅरेक्टर होण्याचे त्याच्या दोन गोष्टी आहेत. पहिली गोष्ट म्हणजे हा जो नायट्रोजन इथे आपल्याला दिसतो आहे, हा नायट्रोजन डबल बॉन्डेड राहतो, ह्याच्यावरती पॉझिटिव्ह चार्ज येतो आणि याच्यामुळं याचे जे पर्सेंटेज ऑफ एस कॅरेक्टर जे म्हणतो आपण, है ना, म्हणजे एखादा जर नायट्रोजन हा sp3 नायट्रोजन असेल, जो आपण ॲलिफॅटिक नायट्रोजन म्हणतो, त्याच्यामध्ये कुठलाही डबल बॉन्ड आपल्याला पाहायला मिळत नाही, असा नायट्रोजन जो काय आहे sp3 आहे, अशा sp3 नायट्रोजन मध्ये देर इज अ 25% ऑफ एस कॅरेक्टर. ओके. आणि जो दुसरा डबल बॉन्डेड असतो, ज्याच्यामध्ये डबल बॉन्ड दिसतो आपल्याला, असा नायट्रोजन जो sp2 हायब्रिडायझेशन मध्ये असतो, त्याच्यामध्ये किती एस कॅरेक्टर असतात, 33% एस कॅरेक्टर, म्हणजे जास्त एस कॅरेक्टर आहे. आणि जेवढे जास्त एस कॅरेक्टर असेल तेवढं तो स्ट्रॉंगली इलेक्ट्रॉनला होल्ड करू शकतो, म्हणजे तो दुसऱ्याला देणार नाही. ओके. आणि अशा केसमध्ये इलेक्ट्रॉन द्यायच्या ऐवजी तो काय करेल, स्वतःचा प्रोटॉन इथं लॉस करेल, म्हणजेच काय होईल, तो H पॉझिटिव्ह देईल. and if it gives the H positive, then this species is known as to be acidic species. ठीक आहे. तर आपण इथे थांबूया. इफ यू हॅव एनी क्वेश्चन यू कॅन आस्क. हॅलो हॅलो.